Even when the head is held erect as in the figure, its center of mass is not directly over the principal point of support. The muscles at the back of the neck should therefore exert a force to keep the head erect. That's why your head falls forward when you fall asleep in class. Calculate the force exerted by these muscles using the information in the figure. What is the force exerted by the pivot point on the head? Alright, so what is given here? We are given R sub m. That's the distance from the pivot point where the force exerted by the muscle. That's equal to 5.0 centimeter. And also for the RW is given, that is the distance from the pivot point to where the weight is exerted. That's 2.5 centimeters. And what else do you know? We know the weight of the head, which is 50 newtons. Alright, so what is A asking for? What is the force exerted by the muscles? And we know that summation of all torques must be equal to 0. Alright, so what are the upward forces and what are the downward forces? I have actually this Fm tends to rotate it in this direction, that is counterclockwise direction. And the weight tends to rotate it in this direction, that is clockwise direction. Therefore, our equation is going to be F sub m multiplied by R sub m minus W, the weight, multiplied by the corresponding distance R of should add up to 0. Rearranging, F sub m will be equal to just adding W times RW to both sides and then dividing by R sub m. That yields RW over Rm into the weight. Therefore, F sub m will be equal to Rw is given to be 2.5 centimeters, and R sub m is given to be 5 centimeters. Multiply that by the weight, which is 50 newtons. That yields 25 newton downward. And B is asking for calculate the force exerted by F sub j. Alright, so this force here. And we know the summation of all force must be equal to 0 in order for it to be in equilibrium. And we have the force upward Fj minus F sub m plus W should add up to 0. That means F sub j equals to F sub m plus W. Plug in the numbers. F sub m we have calculated in A is 25 newtons, and F and the W is 50 newtons, and that's equal to 75 newtons. So the force exerted by the pivot is 75 newtons up.